Hey everyone. We hear all the time that AI can see, but can it really understand what it's looking at the way you or I would? I mean, it's one thing to just recognize an object, but it's a whole other ballgame to get this story a picture is telling. Today, we're going to dig into some really cool research that's teaching an AI to do exactly that. Okay, let's just jump right in. Look at this picture and answer this question. Is the happy man on the left or right of the boy in red? For you, that was probably instant, right? You see the man, you register he's happy, you spot the boy in the red shirt, and you immediately know where they are in relation to each other. But for a computer, whoa, that is a minefield of complexity. To get that right, an AI has to connect a whole bunch of different ideas. An object, its emotion, another object, its color, and their spatial relationship. For years, these kinds of compositional questions have completely stumped AI. So in this explainer, we're going to break down how a brand new model finally cracked the code. All right, so to really get why this is such a breakthrough, we first need to understand the problem they were up against. This whole field is called visual question answering, or VQA for short. The goal sounds simple enough: build an AI that can correctly answer a question about a picture. But actually doing it is incredibly hard. And this isn't just some academic exercise. This has huge implications for things like self-driving cars and even medical AI. And here's where the problem really shows up. Older AI models, they're actually pretty good at simple stuff like what color is the car? But they just fall apart when you give them something complex and compositional. I mean, to answer the question on the right, the AI has to find the sign, notice the snow, locate the words underneath the snow, and then figure out their color. It's a whole chain of reasoning. This really gets to the heart of it. As the researchers behind this very model said, previous AIs were great at listing all the ingredients in an image, but they just couldn't figure out the recipe, the relationships between all those ingredients. And that's the exact problem this new approach was built to solve. So how'd they do it? Well, the solution starts with teaching the AI a totally new way to look at an image. To make this super easy to follow, let's just think of this new AI as a detective. And its first job isn't to just glance at the crime scene, it's to meticulously gather every single possible clue from that image. So the key here is the quality of the clues. A basic AI just lists objects: man, boy, shirt. But this new model, using a powerful tool called a vision transformer, pulls out what the researchers call high-level semantic information. It doesn't just see a man, it sees a happy man. It doesn't just see a shirt, it sees a boy in a red shirt. And it gets their relationship, left of. It's starting with a much, much richer set of clues. But having a mountain of clues is only half the battle. A good detective knows which clues actually matter and which ones are just noise. And that's the next brilliant piece of the puzzle. The model has an information filter that's basically designed to cut out redundant information and background noise. It's like the detective's instinct to ignore all the distracting stuff and focus only on what's relevant to this specific case. So here's how our detective cracks the case. After it gathers and filters all the clues, it uses this incredible technique called a multi-layer attention mechanism. This lets the AI literally link specific words from the question, words like happy or red, directly to the visual evidence in the picture. It's this precise connection between the language and the pixels that solves the whole thing. Okay, so that's the theory. It sounds great on paper, but does our AI detective actually get results? Let's look at the data. And the results are, well, they're staggering. On one data set that is packed with these kinds of complex compositional questions, the new model got a massive 19.5% accuracy boost over a previous top-of-the-line model. That isn't a small step up, that's a giant leap forward. And on another big-time benchmark test, it's the same story. You can see here, while all these other top models are kind of hovering in the low 70s for accuracy, this new proposed model just jumps way up to over 82%. It's just flat out better. This chart makes the difference even clearer. Because this test really focuses on those tough relational questions, the new model isn't just a little bit better. It's playing in a completely different league. This proves its real strength is tackling the exact kind of complex reasoning that's been so tough for AI in the past. So the model is impressive. The numbers are fantastic. But what does any of this mean for the real world? Why does this actually matter? Well, the potential applications are incredibly exciting. Imagine being able to search your photos by asking, "Find photos where I'm standing to the left of my sister." Or think about intelligent driving systems that can truly understand a chaotic traffic scene. Or even a medical AI that can help a doctor by answering detailed questions about an X-ray. This technology is a key building block for a much smarter AI.
So really, the big takeaway here is this. We are watching a fundamental shift happen. This research is a major step away from an AI that just processes pixels and toward an AI that actually comprehends the rich, relational, and messy world we all live in.
And that leaves us with one last fascinating thought. For so many years, we've been limited by what our AI could understand. Now that it can start to see the world with more human-like context, the possibilities are just blown wide open. The only question left is, what will we ask it to see for us next?